Hello everyone. In this video, we're going to see the prefix sum problems. Okay, so we will start from a easy problem, and that is find pivot index, and its number is 724 in LeetCode. Okay, given an array of integer nums, return the pivot index of the array. Okay, so what does this basically mean, guys? Okay, so pivot index is the index where the sum of all numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the right of the index. What does this mean? Okay, so if you see in this array, okay, 173656, right? So if you add them 1, 7 and 3, we get 7, 1, 8 and plus 3, 11. And if you come here, 5 plus 6 is 11. So 6 is an index. This is in the middle, right? So uh, so numbers left of 6 gives us 11 if we add them, and numbers right side of the right side of 6 gives us 11, right, if we add them. And 6 is in the middle, and what's the index number of 6? 0, 1, 2 and 3. Okay, so here in this case 3 is going to be the output, right? So this is the thing we need to find out by programming, right? So I'm going to show you its solution. I'm going to simulate the solution, and I will explain this nicely to you, and we will see, if possible we will see time and space complexity, right? So come in this solution. So let's say, okay, this is our solution, guys. Okay, what we're going to do, spelling ignore all, current document, do not check spelling. Okay, these red signs are really, I don't like them, but I don't know what to do with them. Okay, it's gone now. Okay, so we know that our program starts from the main function. In LeetCode we don't paste, we don't provide the main function. We don't need it in LeetCode, but here we do this because we need to see how the output is coming and everything, right? So we have this array here, so let's just copy this, and the num size is, we are finding the num size. Okay, so the size of nums divided by size of nums 0. Okay, so whole array is being divided by the size of the first one, and then our computer can understand how many numbers are there, and result equals pivot index. So you see there is no pointer here, or because we will just return only one number, right? So this is why we don't need any pointer or anything. So we need to go to the pivot index now. So here's the pivot index, right? So total sum equals 0, left sum equals 0. So we will see why we need it. Okay, so we need to find the total sum. So calculate the total sum of the array. So if you see here, last iteration of this, so this for loop is giving us the total sum of them. Okay, so 1 plus 7, 8, 8 plus 3, 11 plus 6. So this is how we will get 28, right? So if you see, I starts from 0, and num size is 1, 2, 3, 4, 5, 6, right? So there are 6 numbers here, and total sum is uh, first iteration total sum is 0, right? So 0 plus num size 1, right? Num size I is 0. So in 0th position we have 1. So 0 plus 1 equals 1, and this 1 is stored in the total sum again. And then we have second iteration, I is 1. So here we have, in previous iteration we had 1, total sum 1, and now here we have 1 plus 7 equals 8. And then third iteration, 2. So here we will get 8 was in our previous iteration, so 8 plus 3, this is how it will work, guys. Okay, 8 plus 3, we will get 11. So this is how all the iteration will carry on, and we will get the final result, right? If you want, you can I can stop here, but I'm just showing you. Okay, so this should be 3 here, 0 1 2 3. So 11 plus 6, 11 plus 6 would be 17. 17 plus 5 and 6, this is how it will work. Fifth iteration, here this should be 4. So 17 plus 5 would be 22. 22 plus 6, this is your last iteration, right? In the last iteration, we will get 22 plus 6, right? So we'll have 28. So finally we are getting 28, right? So aim of the array was to give us the total sum of the array. Okay, now we have traversed the array to find pivot index. There is another for loop we have here. Traverse the array to find the pivot index. Okay, so what we will do here, I'm going to show you guys. Okay, if we come here, I starts from 0, right? And num size would be 6. So here if you see, check if left sum equals to the right sum. So what we are going to do, you will understand in the third or fourth iteration, right? You just see now. So left sum is 0, right? So 0 equals total sum minus left sum minus 1. What we are going to do here? Okay, so left sum is 0 now. I'm going to show you in the third or fourth iteration, you will realize this really nicely, right? Total sum is 28 minus left sum is 0 minus num psi is 1, right? So this will never be equals to 0, because 28 minus 1 only 27. So we can't this condition would be false, right? This condition is false. So update the left sum. So if you update the left sum is 0 plus num psi 1 equals to 1. Okay, so let's go to the second iteration. Let's go to the second iteration. I is 1 here, 1 is less than 6. Yes, this is true. Left sum would be 1 minus 28 minus left sum. Now left sum is 1 minus num psi. Okay, num psi is 7 now. So 7, 28 minus 1, that means 27. 27 minus 7, it will be 20. So this is not equal to left sum 1. Okay, so this is going to be false again. So left sum is, this time left sum is 1 plus 7. This should be 8 now. Okay, so let's go to the third iteration. You will now understand, guys, what it's doing, right? Third iteration. So here I would be 2. 2 is less than 6. Yes, fine. So left sum is equal to 8, right? Left sum is 8. Total sum is 28 minus left sum 8 and minus I is 2. So in this position we have 3, right? So what we are doing, from the total sum, from this all the sum, from this total sum, we are just deducing left sum and another number. So what is actually we are doing? Okay, if you see the left sum 8, left sum 8 is the sum of the first two, and then we are deducing one 3 as well. Do you understand? So what we are doing, this 8 means, guys, sum of these two and then another one. So that means we are just deducing numbers from left sum, I mean total sum, and we want to see if this is equal to the left sum, right? So finally, we are deducing in two steps, left sum minus 3, but actually we are deducing these 3, and then these 4, and then these 5. So this is how we are trying to understand which deduction gives us uh, you know uh, equals to left sum, right? So here you see uh, this is giving us 28 minus 8, 20 minus 3, 17, right? So this is not equals to the 8. Okay, so left sum is left sum is addition of these numbers, and then we are going to the fourth iteration. You just need to feel, guys. Sometimes you can't explain everything, but you just need to feel what's going on, right? So you come here 3. So here, okay, did we do this operation here? One, no, we didn't. So 8 plus 3 in the third iteration we need to do it. 8 plus, here this would be 3, 8 plus 3 would be 11. In here we see in this 11 minus 28 minus 11, and then the next number will come, right? 6. If you see here 28 minus 11 minus 6, so 11 minus 6 is 11 and 6, so this is 17, right? So 17, 28 minus 17 would be 11. So in here we see left sum 11, and in this part we have 11 too, right? So in this case this will be true, this is not going to be false anymore. So return I, that means I is 3, guys. Okay, so pivot number, index number, not actually number, the index number of 6, right? So here we will return 3. So this 3 is going to be our output. So after that, if result not equal to -1, okay, so if we couldn't find the result, then the return minus 1 would be returned, right? But we got a number, this is why we are not returning -1. So we need to understand, if we couldn't find any number, then result -1, we could printf the pivot index is result. That means we would print -1, but we got a number, so uh, we got a number, so this is why we pivot index is 3. Otherwise no pivot number index found. So this was our case, right? So if we just if we just see the output, right? You see pivot index is 3. So I hope you got a good idea about the program. Okay, so what we will do, we will try to understand the time and space complexity of this program, right? So this is really necessary, guys. Okay, given the time and space complexity O(n) region, the first loop runs through the array once to complete total sum O(n). Okay, so if you see the first loop, right? If you see the first loop, this one, this is talking about this one. So this loop is running from wants to complete the total sum, so O(n). So this will run how many numbers it has, right? This is O(n), and the second loop runs through the array again to find the pivot O(n). So this is also this also runs from the beginning to end, right? So total O(n) plus O(n) would be O(n). Okay, and space complexity O1 region, you only use a few integer variables, total sum and left sum, and loop counters. no extra arrays of dynamic memory is created, space does not grow with input size, so space complexity remains constant O1. If you want, I can also give you a constant optimized version or a visual dry run for deeper understanding. So I don't actually need the for this. So this is, this is the program we are having here, right? So we are trying to, this part is little bit confusing. Okay, so what we are doing, we are, from total sum we are trying to deduce the left sum. Okay, and what is left sum? And left sum is, a sum, addition of the left numbers. Okay, and then we include another one that is not, in the left sum. Okay, so do you understand? So let's say left sum 11. So 11 comes from 7 plus 3 plus 1. 11 comes from these three, addition of these three numbers, and we are deducing one more number. Okay, to see if it matches the, if it matches the left sum, right? So as long, when, this will be equal to, left part and right part would be equal, then we will directly, exactly return the index number of that number. Okay, so we have to, if we, revise this program, and if we write again and again, then sometime it will be, easy for us, right? So thank you for watching. We will, go for the next program.